conditional probability. For examples, in our class, there are 30 students. 20 are female, 10 are male. Okay, let's say a student A, named A. So what is the probability A will be chosen as the class rep? So the answer is, because of we only have one A, okay, A is the only one in the we only can find one A in the class. So the probability for A to be chosen as a class rep is 1 over 30. So now, if someone told you that, when you choose a class rep, you only allowed to choose male, for example. So as I said just now, 20 are female, 10 are male. So what is the probability A is will be chosen given that only male student will be chosen? So the answer is not equal to 1 over 30 anymore, but the answer is 1 over 10 because of we only have 10 students. So this is what we call conditional probability. So by formally, according to definition 2.10, the probability of B given A will occurs, so is equal to PA and B divided by PA. Is the same. The rationale is the same like what I explained to you, the example I explained to you just now. Okay, so now example 2.36. So you have all possible outcome is 0, 1, 2, 3, 4, 5, and 6. Okay, A is event where you will get 0, 1, 2, and 3. B is 1, 3, and 5. So now if I want you to find what is the probability B will occur given that A will occur. So means that if you find probability of B without condition of A, so B has 3 elements, but S has 7. So the answer is 3 over 7. But now someone told you that some outcome may not happen. Only A will happen. So that's why 1, 3, 5. So you only have 1 and 3 are in common. So that's why the answer is 2 over 4. Okay, 2 over 4. This is one way for me to see the solution. Because of B, what is the probability of B given A will happen? So you are not going to base on S, but you are going to base on A. But if you compare B and A, there are only 2 common elements, which is 1 and 3. So the answer is 2 over 4. So it's 1 over 2. So if you use the equations given by the previous definition, probability of A and B. So probability of A and B they have common is 2. 2 over 7. We still divide by total because of this is not the conditional probability. So divide by PA. PA is what? Is 4 over 7. So when you summarize, when you simplify, the answer still remains the same, which is 1 over 2. Okay, a car is selected from a car park containing 2 black cars labeled as 1 and 2 and 2 white cars labeled as 3 and 4. So number and color of car is noted set up so that the sample space there are 4, 1B, 2B, 3W and 4Ws. So now you have to find the first one is the probability of A given that B will occur and the probability of A given that C will occur. So now we label what is A, B and C. A is black car selected, B is even number car selected, C is number of car is greater than 2. So now if you compare A and B, if we say A and B, A intercept B, there will be only one common element, which is 2B. So A and C, because they have no common element, the probability of for you to get A and C is equal to 0. So now we find the probability of A given B. So given B, only B will happen. So but there is only one common element, that's why the answer is 1 over 2, 0.5. If you use the definition equation, you will get the answer is equal to 0.5. Okay, but now if you think properly, how about if we find the probability of A we have 1B and 2B, and total sample space we have 4. So is 2 over 4 is also 0.5. So it means that this is a special events where even with condition or without condition, A probability of getting A is still is the same. So we say that A and B are independent. But for the other case, the probability of A given that C will happen, because of A and C, they have no common elements, so that's why the probability must be equal to 0. Okay, what is the probability given A? What is the probability of A given that C will happens? So, but A and C no common element. That's why the probability of you to get A is 0. And for this case, with condition C and without condition C, their probability value is not the same. That's why we say A and C are not independent. Okay, example 2.38. Okay, the probability that a regularly scheduled flight depart on time, we say probability of D is equal to 0.83, and the probability that it arrive on time PA is 0.82. Okay, and the probability that the plane will depart and arrive on time is 0.78. So now we want to find A and B. Okay, the probability a plane will arrive on time given that it departed on time. So now for this one we have to use the equation. So now we want to find what is the probability of A given that D will happen. So it means that arrive on time given that it depart on time. So PDA is 0.78 and PD is 0.83. Then we get 0.94. So now B is probability of D given that A will happen. So A and B, they are totally different. Okay, because of they based on different conditions. So for this one, when you calculate, okay, the probability value is equal to 0.95. Okay. The population of adult in a small town is categorized according to gender and driving record status. One of these individuals is to be selected at random for a tour throughout the country to publicize the advantages of establishing new road safety program in the town. Find the probability that a man is chosen. The man is chosen, and given that he has a good driving record. So now we are given a tables. We have male and female on one side, good and bad record at one side. So then we have the figures here. So now to find the probability a man is chosen given that he is a good driving record. So means what? We only based on look at the goods, the column labeled with goods. So means that only good people, good records, good reputation people will be chosen. So that's why the answer is for this one, the probability a man is chosen given that he is having a good driving record is 460 divided by 600, and you simplify it, the answer is equal to 23/30. So this is the first way. I will use this way to see the answers. But if you use a definition equation given by definition, so you have to find the probability of man will be chosen given that he has a good record. So now we use this probability of a man will be chosen and he has a good record. So how many of them? Okay, good record and the man is there 460 divided by 900, and probability of good record is 600 divided by 900. So when you simplify, you will get the same answers. So it means that for you to answer this question, you can use deal two different way, okay, to provide to find the answers.